Hello, I'm Cheryl. In this problem, we're asked to find a set of parametric equations that represent the tangent line at the point 1, 1, 1 to the curve that's created by finding the intersection of the surface x squared plus y squared equals 2 and the surface z equals x. Well, that first surface is a cylinder, and my second surface is a plane. So if you think about a cylinder and you slice it with a plane, and it's going to be coming through towards you, okay? And that's a little hard to visualize. So what I'm going to do is I'm going to kind of turn it around, and you can see here that we have a cylinder, and if you slice it with a plane, the intersection is going to be an ellipse. So what we're trying to do is find parametric equations for the tangent line of that ellipse at the point 1, 1, 1. Okay, so we're going to begin by looking at the gradient using functions created by those two surfaces. So first of all, let's take a look at the cylinder. If I look at the cylinder, I'm going to look at the function f of xyz equals x squared plus y squared minus 2. Okay? And I'm going to look at the gradient of that function. So the gradient of f of xyz is going to be the partial with respect to x, so that's 2x times my vector I, plus the partial with respect to y, so that's going to be 2y times vector j, plus the partial with respect to z, which is just 0k, so 0k. And I'm interested in what's happening at the point 1, 1, 1, so let's take the gradient at 1, 1, 1. So that's going to be 2i plus 2j plus 0k. All right, now let's do exactly the same thing, but we're going to look at the plane. So for my plane, I'm going to create a function g of xyz, and it's going to look like x minus z. And I'll look at the gradient of g. So the gradient of g is going to be the partial with respect to x, so that's going to be 1 times my vector I, plus the partial with respect to y, which is 0, times my vector j, plus the partial with respect to z, so that's negative 1, times my vector k. So that becomes I minus k. Now I'm interested in what's happening at the point 1, 1, 1, but it's interesting to note here that the gradient at 1, 1, 1 is still just I minus k. All right, now we know that the gradient gives us the direction of a normal vector. So I'm looking for a tangent. Well, if I take the cross product of these two vectors, then let's take a look at that. If I take the cross product of those two vectors, as long as those vectors are not the 0 vectors, which they're not in this case, I know that each of them, well, this one will be normal to the cylinder, this one will be normal to the plane, and when you take the cross product, they'll be orthogonal to each other. So that means that you're going to have something that's coming out, you've got two vectors, and it's going to be coming orthogonal to both of them, which means it's going to lie in the tangent plane of that intersection. So let's go ahead and take the cross product then. I know to take the cross product, I need to look at my vectors I, j, and k. And for the gradient of f, I'll be looking at 2, 2, 0. And for g, I'll be doing 1, 0, minus 1. So when I take this cross product, I'll have vector I times a negative 2 minus 0 minus vector j times negative 2 minus 0 plus my vector k, times 0 minus 2. All right, and that's going to give me a minus 2i plus 2j minus 2k. And if you want to, you can even factor out a minus 2. And that's going to give me I minus j plus k. All right, now, this is going to give me the direction of my tangent line. So remember, I'm looking for parametric equations of a line. So my parametric equations will always take the form x equals x1 plus the direction times time. And in this particular case, that means that x is going to equal 1 plus the direction is 1 times t. Y, on the other hand, is y1 plus its direction times time. So y is going to equal 1 plus its direction is going to be negative 1 times t. And finally, z is going to be z1 plus its direction times t. So z is going to equal 1. Its direction is a 1. So that's 1 times t. So my parametric equations then become x equals 1 plus t, y equals 1 minus t, and z equals 1 plus t. And I have a set of parametric equations that represent the equation of a tangent line to my ellipse at the point 1, 1, 1. I hope that was helpful. Thanks.